Hey guys, welcome to Math Cube. Today I'm solving the 10th question and the final one from the International Advanced Level Pure Mathematics P4 Jan 2021. So let's get started. The A part, write 1 upon h minus 5 in brackets h plus 3 in partial fraction form. So that's of 3 marks. I'll just go down and write the equation again and solve it. So to solve this as partial fraction, what we'll do is we'll set some number or some alphabet that's a whenever we have x in terms of h. Today we have h, but for normally we have x values at x minus 5 and x or x plus 3. So that's a quadratic function when we simplify using FOIL method. But now what we'll do is we'll just use alphabets and I'll show you. Here you go. A upon h minus 5 plus b upon h plus 3. This is due to the denominator being greater degree of respect to the numerator here. So what we'll do is we'll multiply both the sides of both sides with h minus 5 h plus 3 and we find that a is there you go. That's how we obtain it, or you can usually do cross multiplication like that. Multiply like that will be too easy for you. And now what I'll do is I'll just expand the bracket. There you go. Ah plus 3a plus bh 5b. We know that we don't have an h value on the numerator, so our ah plus bh will be set to 0, and we know that our single a values, that's ba minus 5b, that's equal to 1. So we can set a simultaneous equation. So to eliminate one function I can choose b, and that's a second equation. That's a second and that's a first equation. So what I'll do is I'll multiply the second equation with 5 both sides. There you go. So what I'll do is I'll just cancel minus 5, or I'll just add these both equations, and that'll just cancel 5b and 5bh. I'll be left with 1, or I can say 1 equal to 8a, and to obtain a I'll divide both sides with a, and that'll be, and to find b what I'll do is I'll use my first equation and plug in this value of a. So I find that my b is equal to minus 1 upon 8, and now what I'll do is I'll write it in the partial fraction form, and that'll be written as, there you go. That's how it's written in the partial fraction form. 1 upon 8h minus 40 minus 1 upon 8h plus 24. I just took 8 on the both downside on here and multiplied with the brackets. That's all it. Now that we are done with the A part, moving on to the B one. The depth of the water in a storage tank is being monitored. The depth of water in the tank h meters is modeled by the differential equation dH upon dt equal to minus h minus 5 h plus 3 upon 40, where t is in time in days from when monitoring began. Given that the initial depth of the water in the tank was 13 meters, B part is solve the differential equation to show that h is equal to 10 plus 3e to the power minus 0.2 t upon 2 minus e to the power minus 0.2 t. So let's get started. Now to solve the differential equation, what I'll do is I can either take this whole function, that's, so I'll multiply this function, take it downside, cross multiply, dt will come up. So it will look something like, there you go, dh upon h minus 5 and h plus 3 equal to integrating minus 1 upon 40 dt. Now this function right here, this one and this one, these are two different functions. This function right here is in terms of dt, and this is in terms of h. So what I'll do is I'll first integrate the dt one. We know that we have minus 140 as a normal number, and I told you previously that we integrate anything with respect to t or x or anything, we'll add a t here. So that'll become, there you go, we got our first integral, that's 1 minus 40 upon t, that's t and dt. And now what I'll do is I'll integrate this function, and if you remember, uh, I got the partial fraction form of this function as this 1 upon 8h minus 40 minus 1 upon 8h plus 24. And now what I'll do is I'll just integrate it, and to integrate it, we know that anything or upon 1 upon x, the integral of it is natural log of x. within the abstract. So it's ln of x. If you have covered the integration topic from P4, so what I'll do is, there you go, integrating the partial fraction, I'll get 1 upon 8 ln h minus 5 minus 1 upon 8 ln h plus 3 equal to minus 1 upon 40 t dt plus t. And this function right here has a d of h. I forgot to mention it, but never mind. Now, if you remember, they said that when t is equal to 0, the depth of the water tank will be equal to 13. So h is equal to 13. And now what we can do is, we can just substitute these values to find this value, that's c. There you go. When I plug these values, t equal to 0, I get it 0. And when I plug h as 13, I get 13 minus 5 as 8 and 13 plus 3 as 16. Now, if you guys know that in logs, when we subtract anything, such as 7 minus 3, that equally means that anything is 7 upon 3. So that will be 1 upon 8 ln 8 upon 16 equal to c, and we know that 8 upon 16 is half. There you go, that's our c value, 1 upon 8 ln half. Now I'll write the whole function as substituting c in. There you go, 1 upon 8 ln h minus 5 minus 1 upon 8 ln h plus 3 equal to minus 1 upon 40t plus c, and that's 1 upon 8 ln 1 upon 2. And now they said that we have to make h the subject. I'll simplify this side first. So this is how our product will take shape. In case if you're wondering how did I get 5, that was, I had 1 upon 8 generally in front of every h function, and I just substituted 40 on the upside, so that's 40 upon 8, and that's 5. So that's how I got. So to remove the fraction, I multiplied both sides with 40, and I got this function. And now, what we'll do is, we have lns on both sides. So to remove ln, what I'll do is I'll multiply both sides with the exponential. That's e. There you go, half e into minus 0.2t. Originally, I was left with ln of half. So when I basically I had ln of half, and when I multiplied it with e, I got e. Ln e is basically 1, and I got half. So what I did is I set e to the power ln half and into e, that will give me half, and 0.2 came as 1 upon 5 we had previously. There you go, I cross multiplied my earlier function, that was h plus 5, sorry, h minus 5 upon h plus 3. Just cross multiply and we get this function, 2h minus 10 equal to he to the power minus 0.2t plus 3e to the minus 0.2t. And now what we'll do is, I'll take h to this side and bring 10 to the other side, that make it positive. Now that I have h on the other side, I can take h as common factor, and that'll be. And now to make h the subject, what I'll do is I'll divide both sides by 2 minus e to the power minus 0.2t, and we'll get h as h equal to 10 plus 3e to the power minus 0.2t all over 2 minus e to the power minus 0.2t. And if you see the the c part, we have clearly shown our differential equation, and that's our 7 marks, 3 marks up to now. And moving on to the c part,